I'll do example 2 twice. First I'll perform long division and then I'll perform synthetic division. The results are supposed to be the same, but we'll see the difference between the two techniques. Okay, so we want to evaluate the following division of polynomials. We want to evaluate 2x cubed minus 7x squared plus 5 divided by, this time, x minus 3. Okay, A, by long division, B, by synthetic division. So this will give me the opportunity to teach you synthetic division. Unless you've done this already, which most of you have done, so I commend you for that. So by long division, this is basically the same thing, but there is something that you need to be mindful. And the fact that we do have 2x cubed, and we do have negative 7x squared, but we have no x in it. So leave a space here, or even write a 0 here, and then add 5. Okay, so we don't have anything in the x position. Remember, this is like working with number placement, and the divisor is x minus 3. So we need to get to 12x cubed. To accomplish that, we multiply by, I'm sorry, it's 2. This line is the separation line. Let me make a correction. It's 2x cubed. I didn't realize that I've already drawn this. Here we go. Like so. All right, so to get to 2x cubed, I need to multiply by 2x squared. The position is right here, so I'll put it above the x squared position and get 2x cubed. And then 2x squared times negative 3 gives me negative 6x squared. And I'm subtracting, and the x cubed term disappears. Here we have positive 6x squared, so we end up having negative x squared. And we drop the 0 because we don't have the x term. Okay? And now to get to negative x squared, I need to multiply x minus 3 by negative x. And I do have negative x squared and plus 3x. Subtract and get negative 3x plus 5. And I need to multiply by negative 3 to get negative 3x. Negative 3 times negative 3 is positive 9. Subtract and get negative 9, positive 4, negative 4, and that's it. So this is my remainder, and this is my quotient. Okay? So this is the quotient, and this is the remainder. Writing it out, the result, we're going to write, again, I'll write it twice. I write it as first 2x squared, sorry, 2x cubed minus 7x squared plus 5 when divided by x minus 3 results in 2x squared minus x minus 5 plus the remainder is negative 4 over x minus 3, like so. I'm sorry? It's minus 3, not minus 5. It says 3 here. Again, you don't see well. And using the division algorithm, this can be written. What page? 6 now? This can be written as, so this is one answer. Let's box it. And I can write it as 2x cubed minus 7x squared plus 5 is x minus 3 times the quadratic 2x squared minus x minus 3 plus the remainder, or minus the remainder 4, like so. Okay. Now, what the result above tells us, what will be the long-term behavior of this, of a rational fraction? Remember, when we divide polynomial, we have something called rational function. What will be the long-term behavior of this particular rational function, which is the quotient of two polynomials? As before, when x goes to infinity, the remainder disappeared. What's left is a parabola, 2x squared minus x minus 3. So if we have if we zoom out on this function, what we're going to see is a parabola. Okay? If you graph this thing, you'll see just a parabola. But we'll talk about it later on. We'll go back to long-term behavior of rational functions. So I'm addressing something that a little bit down the road. So this was long division. Let's do synthetic division. Okay, synthetic division should give us the same result. What we'll do when we do synthetic division, we're going to look just at the coefficient of the dividend. Okay, so we'll start with the top row will be the coefficient of the dividend. Well, that would be 2, negative 7, and don't forget that we don't have the x term. So instead of so the actual coefficient would be 0 times x, as I said before. So we have a 0 here, and then we have 5. Okay. To the left of this, we're going to put, instead of x minus 3, we're going to put just 3. Okay. The general form of the divisor, if the divisor is a linear function, we're going to write it as x minus c, a constant c, and in this case c equals 3. So we're going to place 3 right here. I'm going to discuss this a little bit more down the road. Okay, so now we're going to skip a row, and the result will be the bottom row. Okay, so we have a top row like so, and a bottom row. And what we're going to do, first we're going to drop 2, because we know that in order to get to 2x cubed, I need to multiply by 2. Now, we'll multiply 3 times 2, that's 6, and write it under the 7. And now I'm going to add negative 7 and 6. Okay, so basically what I did here, I moved the 2 down this way, like so. And now I have negative 7 plus 6, well, that will be negative 1. 3 times negative 1 is negative 3, so I'll write negative 3 here. 0 and negative 3 is negative 3. 3 times negative 3 is negative 9. Write it here. 5 and negative 9 is negative 4. This is the remainder, and this is the coefficient of the result. Okay? So this is the coefficient of the remainder is negative 4. Well, the remainder is negative 4. The coefficient of the quotient is 2, negative 1, and negative 3. So we're going to say that the result will be, again, we'll write 2x cubed minus 7x squared plus 5 divided by x minus 3 will be the 2 times x squared will be the negative 1x and would be the negative 3, and then minus 4 over x minus 3. It's quicker. It's quicker, but you have to have a form that is x minus c to come up with it. Okay, so here's the something called the remainder property or remainder theorem. It's easy to prove it, really. It says the following, that if P of x is divided by x minus c, okay, this is the general form of a divisor that is first order divisor, just a linear divider, then when P of c, if we evaluate the polynomial for c, then it's equal to the remainder. Okay. So let's verify this for in the next example. This was example 2. So example 3, we're going to say verify the remainder theorem for the first example was what? The first, I'm sorry? X minus c, right. That's you're going to see it in a minute as we're going to do some stuff here, some more examples. But here's the example that we started with. If you remember, this was. By the way, am I missing one example here? Because here I had. Yeah, I'm missing one example. So, what was the previous example? The previous example was 6x squared minus 26x plus 12 divided by x minus 4, right? But remember, that the remainder was, if this is, I'm just writing the result of the example. That was example 1. Okay. Remember this, we end up having 6x minus 2 plus 4 over x minus 4. So this was the remainder, 4. Okay, so let's see, if we need to evaluate P of 4, so C equals 4, because we divide by x minus 4. Actually, from here we get let me write it here underneath, because C and the remainder here are the same, so this may confuse you. X minus C is x minus 4, therefore C equals 4. And if we want to evaluate P of 4, then let's see, we have 6 times 4 squared minus 26 times 4 plus 12. Okay, based on the theorem, we're supposed to have the remainder. So P of 4 is supposed to be 4. But let's see if this actually works out. 6 times 16 is 96. 5 times 16 is 80, plus 16 is 96. 26 times 4, well, 25 times 4 is 100, plus 4, so it's negative 104, and then plus 12. So 96 minus 104 is negative 8. Negative 8 and positive 12 is 4. Okay? So you can see that it's equal to the remainder. So we didn't have to evaluate it. We could have done it directly by looking at the remainder.